This lesson is 5, which is on combinations. If we look at the targets, I can count using combinations. I can compute a combination based on a permutation, so we're going to talk about the relationship between combinations and permutations. We're also going to talk about the relationship between combinations and Pascal's triangle. And then a lot of what we're going to do today is be actually counting using combinations, but counting in conjunction with the multiplication rule, which we've already learned. Okay, specifically we're going to talk about a lot of different poker hands for those of you who are poker players. Okay, combinations are used when order is not important. So if you remember previously we talked about permutations, which was all about order. This is not order, we're just choosing a group. So we read this combination much like we read permutation. It's a combination of n choosing our thing. So from a group of n, how many different ways can we choose a group of r? So for example, if set S has Ann, Bob, Sid, and Dan in it, and a committee consists of 3 of those 4 people, let's try listing all the different 3-person committees. Clearly, order would not be important here. We could pick Ann, Bob, and Sid. We could pick Ann, Bob, and Dan. I could pick Bob, Sid, and Dan. I could pick Ann, Sid, and Dan. So I've come up with just 4 ways because, of course, if I pick in the order Sid, Bob, Ann, that's the same committee as this one. All right, a little different than when we did the same piece with permutations. So the combination of 4 things, how many different ways can I make a group of 3 of them? That comes out to be 4. The actual calculation for this, let's jump down to permutations for a minute. If you remember from permutations, we took the number of things, we took the factorial, and then we divided by n minus the number you were choosing factorial. So combinations is going to be really similar. We're going to start out the same way, but now we have to eliminate all the different ways these could be arranged because, of course, Ann, Bob, and Sid is the same as Bob, Sid, and Ann, or Sid, Bob, and Ann, etc. So to eliminate those, we also divide by our factorial. So another way to think about this is basically it's taking a permutation and dividing by our factorial to get rid of the orders. Okay, so combination order is not important, permutation order is. And here's what we just talked about. A combination is a permutation divided by our factorial. All right, so let's look at example 2. There are 8 people on a basketball roster. In how many different ways can the coach select the starting 5 players? Order is not important. Either you're a starter or you're not a starter. So let's talk about the different ways we can do this. Right? If I'm going to use slots with permutations, I have 5 spots to fill on the team. So I have 8 choices for the first one, since there are 8 people on the roster. I have 7 choices for my second starter, 6 choices for my third starter, 5, 4, etc. But of course, then we'd need to get rid of the ordering, so I would have to divide by 5 factorial. That would be one way to get it. Or I can also use, whoops, I just realized I'm not on the screen here. I apologize that. So again, slots, I had 8 choices for the first one, 7 choices for the second one, 6 choices, then 5 choices, then 4 choices. But of course, since we're just choosing a group, right, I have to divide to get rid of the ordering issues. I have to divide by 5 factorial. So that's the slot method. Of course, I can just use the formula. If you look above, here it is. We're having a combination of 8 people on the team. We are choosing 5. All right, so from my formula, that's n factorial. That would be 8 factorial divided by n minus r. So 8 minus 5 factorial divided by r factorial, which would be 5 factorial. That's 8 factorial over 3 factorial and 5 factorial, that is 56. Of course, on your calculator, you can just use the combination button, which is in the same location as the permutation button. Same spot on the calculator, and if you do that, of course, you should also get 56. All right. So for a minute, let's compare the results of a combination of 8 things choosing 5 and a combination of 8 things choosing 3. So let's compare the formulas for a minute. This is 8 factorial over 8 minus 5 factorial and 5 factorial. And combination of 8 choosing 3 is 8 factorial over 8 minus 3 factorial and 3 factorial. So we can see from above here, this one came out to be 8 factorial over 3 factorial, 5 factorial. This one comes out to be 8 factorial over 5 factorial, 3 factorial. So you can see that these two are equal. I'm having paper issues on this video. I apologize. So combination 8 choose 5 comes out to be this. Combination of 8 choose 3 comes out to be this. We can see that those have the exact same values. They are equal. So what is the relationship? I hope you can see what's key here is that this only worked because the 5 and the 3 together add up to the total number, which is 8. So when we do this subtraction process, these numbers are just going to flip-flop, and they will always come out the same. So, see if I can get this right this time. Here, if we can apply that same principle, I have a combination of 20 choose 15, and I'm asking you that's the same as a combination of 20 choose what? So if you remember, the two numbers, if it's going to work, have to add up to be the total number. So these two numbers would have to add up to be 20, therefore x would have to equal 5. All right? And to calculate that, you could do 20 choose 15 or 20 choose 5, and you would get the same number. So x is 5. All right, let's see how this connects to Pascal's triangle. At the top of the next page, hopefully you're a little familiar with Pascal's triangle. All right, Pascal's triangle starts out with 3 ones in a triangle position, and then we work our way down by adding the 2 that are there, and then the ends are always 1s. And so now I would add 1 plus 2 is 3, 2 plus 1 is 3, and the ends are 1s. 3 plus 3 is 6, 1 and 3 is 4, 3 and 1 is 4, and the ends are 1. So I can keep working my way down. 5, 10, 10, 5, put some 1s on the ends. We'll make one more line. This would be 6, 15, 20, 15, 6, and then I'll put my 1s on the ends, and you could keep going. All right, so the question is, how does this relate to combinations? And specifically here I'm asking combination of 4, 3. Well, what happens here is, if I take this line for example, 1 is the combination of 2 choose 0. 2 is the combination of 2 choose 1, and 1 is also the combination of 2 choose 2. All right, so for this line, if I go in order here, those 4 terms are combination 3 choose 0, combination 3 choose 1, that would be 3, combination 3 choose 2, that's also 3, and combination 3 choose 3, that is 1. So when I ask, using Pascal's triangle, compute the value of 4 choose 3, we can come here to this line, and I know this is 4 choose 0, 4 choose 1, 4 choose 2. This one would be combination of 4 choose 3. So I can see that that would be 4. So I asked you to circle that entry. That would be the one right there. Okay, so that's its relation to Pascal's triangle. You will do more of that likely in pre-calculus. There are some other applications that you will get into in terms of expanding polynomials. Okay, so let's get into the last target, which is probably the most challenging one, which said I can use combinations in conjunction with the multiplication rule to count. All right, a straight combination isn't so bad, but we're going to try to make it a little more interesting here. All right, so we're going to talk about poker. So let's kind of review a deck of cards. We have a standard deck of 52 cards. Remember, there are 4 suits: clubs, diamonds, hearts, and spades. And then there are 13 cards in each suit. a 2 through 10, and then a jack, queen, king, and an ace. And an ace can be high, or you can also think of an ace as low, which would put it before the 2. In 5-card stud poker, each player is dealt 5 cards. So our first question is pretty straightforward. It says if the order of being dealt cards is not important, how many different 5-card hands are possible? So if you're playing, how many different hands could you get? Well, that means out of a deck of 52 cards, right, how many different combinations of 5 could you have? So that, of course, would be 52 factorial over 52 minus 5 factorial, and then getting rid of the orders, divide also by 5 factorial. That's a lot of different poker hands. That's actually 2,598,960. That is a lot of different hands. All right, let's get a little more specific. In 5-card stud poker, a flush is 5 cards in the same suit. Now remember, the suits are clubs, diamonds, hearts, and spades. So you want either 5 clubs, 5 diamonds, 5 hearts, or 5 spades. So here's where we bring in multiplication rule, because you actually have to make 2 decisions, right? We have to pick a suit, so it has to be all clubs, all diamonds, all hearts, or all spades. All right, so I'm going to say of 4 suits, I have to pick one. So I'm going to write down here, choose a suit. Right. But in that same choice, right, in that suit, let's say it happens to be clubs, there are 13 different clubs. Well, I don't need a hand of 13 cards, I only need 5. So within that suit of 13 cards, I have to pick 5. So I'm picking 5 within the suit. So again, if I'm going to have a 5-card flush, they have to be of the same suit. So first I'd have to choose a suit. I have one of 4 suits to choose, and then within that suit there are 13 cards. I'd have to pick 5 of those 13 cards. So that number comes out to be 5,148, which means out of 2,598,960 possible hands, there's only a little over 5,000 chances that you would be dealt a flush. Okay, example C here. In 5-card stud, a 4 of a kind is 4 cards of the same rank. These are the ranks, so that would mean I had 4 2s or 4 6s or 4 queens and one other card. In how many ways can you be dealt 4 of a kind? All right, so first choice would have to be choosing a rank. Well, here are the ranks right here. These, we'll call these right here the ranks, because I have to have 4 of one of those ranks. Well, as you can see here, right, there are 13 different ranks. So I could pick 2s, I could pick 10s. So of the 13 ranks, I have to choose one. All right, so let's say, I don't know, let's say I pick 10s. Now, my next choice is I have to pick all 4 10s because it's 4 of a kind. There are 4 10s in the deck. So of those 4 cards, I need to pick all 4. So I have to choose a rank, and then once I've chosen the rank, I have to pick 4 of those 4 cards. But now notice it's a 5-card hand, so let's not forget this one other card. So I've got 4 of my cards picked, but now I have to pick one other card. Here I'm going to put choosing all of the same rank. And now on my last one, this is where I'm choosing one other card. Okay, so I've chosen a rank. I said 10s, just to be random here. I've chosen 10s. That's one of 13 different ones I could have chosen. Once I pick 10s, I have to pick 4 of 4 10s. But now I have to have one other card. Well, the 4 10s have already been picked. So there are no longer 52 cards in the deck because I've picked 4 of them, which means there are now only 48 cards in the deck, and I have to choose one of those. Okay, so the 48 comes from the fact that the 10s are already gone. I've already chosen those 4 10s. Now I'm picking one of the other cards. If you multiply all that together, you only get 624 ways you could be dealt 4 of a kind. That's why you see it's a fairly rare hand. All right, here's the toughest one. We're going to talk about, in a 5-card stud, we're going to talk about a straight, and a straight is 5 cards in a sequence. So we're actually going to list those out so you can see what they are. Right? An ace can be considered both low and high. So if I start with an ace, I could go ace, 2, 3, 4, 5. That would be one possible hand. Or I could start with a 2 or a 3, etc. So go ahead and list those out. And of course, once I get to 10, the card after 10 would be Jack. And then Jack, Queen, if I start with an 8. 9, 10, Jack, Queen, King. I can actually get one more. If I start with a 10, I would go 10, Jack, Queen, King, and I could make ace high. I can't start with a Jack because I would run out of cards. I would have Jack, Queen, King, Ace, and then that would be too low. All right. So if you look here, let's look at the first cards. Here are the possibilities for the first set of cards. If you'll notice, we have 10 different choices for first cards. So I'm going to say this first slot right here is I'm choosing the rank of the first card. It could be an ace, 2, 3, 4, 5, 6, 7, 8, 9, or 10. So I have 10 choices. Of those 10 choices, I need to choose one of those ranks to start with. But now think about it. Let's just say for an example, let's just say I'm going to start with a 5. I could pick the 5 of clubs, the 5 of hearts, the 5 of diamonds, or the 5 of spades. So my next choice actually has to be the suit. So of 4 suits, I have to choose one of those suits. Okay, so let's say I chose, I don't know, the 5 of hearts. Okay, now we've only chosen one card, so I can see I have 4 more cards to choose from. So let's talk about the second card. The second card has to be a 6. Well, how many 6s are in the deck? Right? There are 4 6s in the deck, so I'd have to choose that. So this is the second card. It must be 1 rank past the first card, which means there are only 4 of those options. If you picked a 7 as your first card, your second card would have to be 8, and there are only 4 8s in the deck, so you'd have to pick one of those. Similarly, if I'm going to pick the third card, it would have to be 1 rank past this card. So if I picked a 6 on this one, this card would have to be a 7. Well, there are only 7 cards in the, or 4 7s in the deck. I need a 4th card, right? I'd be on 8s. I'd have to pick an 8. Well, there's only 4 8s in the deck. And finally, my 5th card, I'd have to pick a 9, but there are only 4 9s in the deck. So these get very specific. Once you choose a first card, right, it can be any one of those 10 ranks. It can be ace through 10. And then on ace through 10, it can be any one of those 4 suits. So this together is choosing your first card. One of the suits and one of the starting ranks. Once you've chosen that first card, right, the second one is very specific. So for example, if I chose a 9 on my first card, my second card would have to be 10s. There are only 4 10s in the deck, and I have to choose one of them. Then there would only be 4 jacks in the deck, 4 queens in the deck, 4 kings in the deck. All right, if you work all that out, I don't think I even have a solution here. You could do that on your calculator. That would get you the number of straights in the deck. That's it for lesson 5.